Hello, AP Calculus students, for another day in Mihawk's AP Calculus class. I hope everybody is doing well. Well, we finally did it, people, even though this is a different place than we would normally do it. But we have finished the AP Calculus curriculum, and now we're basically going to move on to reviewing. So I'll talk about in a moment exactly how we're going to spend our first day of reviewing. But before that, I want us to look at really quickly just the score results from last year's AP exam. I did the same thing last year. So this was the 2019 AP Calculus exam, both the AB and the BC. So this is just a breakdown in terms of how many students took it, how many students got 5s, 4s, 3s, 2s, and 1s, so on and so forth. So if we quickly look at this breakdown, we'll see that the breakdown for the AB students is pretty even. A pretty even number amount got each of the scores. Around 19% got 5s, also around 19% got 4s, 20% got 3s, so on and so forth. So you'll see that the global average for the AB students was around a 3, which was around what last year's scores were as well. So remember what we're trying to shoot for, people. We're trying to shoot for at least a 3. Right, we want to get into this category right here. As I've told you guys before, last year I had 3 students who got a 3, 2 students who got a 4, no students with a 5. Am hoping that this year we'll get that. But remember, in order to get a 5, you basically have to get somewhere in the high 60 percentages. And that will get you your 5. Now, if we look at the BC, which is not the class that we're in, but it's interesting to look at nonetheless, you'll see that the BC score breakdown is very interesting because almost 50%, 43% of students in the BC class got a 5, which just goes to show you. Now, you might be wondering, does that mean that the BC test is easier? It's hard to say if it's easier, but you have to realize the way that some schools do Calculus BC, which is basically Calc AB with just more material thrown in there, is that the way some school districts do Calculus BC is that the year before, students would have taken Calculus AB. And then the next year, students take Calculus BC. So in other words, they get a lot of time to review that AB material. Since BC doesn't involve that much new material, it does involve a couple of additional units, but not anything near as much that could, like the new units are not going to take up the entire year. So a good chunk of BC is spent on just making sure people remember how to do AB. So that is a good reason why you'll see a lot more people get 5s as opposed to Calc AB. And then here at the bottom, you'll see that there's a Calc AB sub-score. For students who take the Calc BC AP exam, they're also given a sub-score, which would tell them what score they would have gotten had they taken just the AB exam. So not surprisingly, as you can see, basically 50% of students got a 5 AB sub-score. So in other words, that is the score they would have gotten had they taken the AB exam, just taking into account just the AB material on the BC calculus exam. All right, so that's just a breakdown. So once again, let's try to get those 3 4s and 5s, people. I definitely believe that some of you are capable of that. So we'll see how that goes. Now, in terms of any updates, College Board, nothing yet, people. We're still waiting on that April 3rd date, which I believe would be this Friday in terms of more information. So we're just waiting on that date. All right. So like I said, we have officially finished covering the AP curriculum. So now we're going to get into reviewing. So the first day of reviewing, what I wanted us to do is I wanted you guys to make some flashcards, basically, on a lot of just the basic concepts that we've covered over the course of the year. So the document that I'll be uploading will have, I basically split it up into a table where if you print it out double-sided, you'll be able to make flashcards by just cutting out the respective rectangles. Or if you want to make flashcards on note cards, you can do as well. But basically at this point, I would advise you to try to figure out as many of those concepts and key terms on your own, and then to go over this video and see how much you remembered, how much you didn't. So please try out doing the flashcards on your own first, and then watch the remainder of this video where you can see what you remembered. So if we quickly go through these, some of these are going to be pretty quick, pretty simple. There isn't going to be much I have to say about them. So let's try and see what you got right. So the first one, the limit as x goes to 0 of sine of x over x. This is one of the limits that I told you could expect to see on the AP exam that you're just expected to remember. So the answer to this, let's see if you got it right, is 1. So the limit as x goes to 0 of sine of x over x is equal to 1. Next one, the limit as x goes to 0 of 1 minus cosine of x over x, let's see if you got this one right, is equal to 0. Now, the reason why both of these are equal to their respective values, you do not need to know the proof of why they're equal to 1 and 0 respectively. They use a concept called squeeze theorem, which is not typically seen on the AP exam. There was one problem with it last year, but it's something we'll get into as we do review. But for now, just remember these two limits are equal to these two values respectively. Next one, the limit definition of a derivative. This I mentioned in the last video on the bell ringer, this idea of if you want to find the derivative of a function at a value, you can use this limit definition. So the limit as h goes to 0 of f of x plus h minus f of x over h. Next one, the alternate limit definition of a derivative. I have seen this definition before on a multiple choice question. I suspect that you can still probably figure it out by doing L'Hopital's rule, but just in case, I do provide it for you guys. So this one looks very similar to the previous one, except instead of f of x plus h, you have f of x minus f of a. But the idea is still the same. You're just taking the slope between two y values and two x values, and then you're just evaluating what happens as that x value approaches a certain numerical value. Next up, the derivative of sine of x. This should be simple, hopefully at this point. You got it right, cosine of x. Next one, the derivative of cosine of x, negative sine of x. Derivative of tangent of x, secant squared of x. So those three definitely I would commit to memory. These next three are not nowhere near as common. You know, sine, cosine, tangent, definitely common. These next three, no. So the next one, secant, the derivative of secant tangent, cotangent. This one is similar to, this one is similar to the derivative of tangent. It's not secant squared, it's cosecant squared, and there's a negative in front. Next one, the derivative of cosecant. This is similar to the derivative of secant. So it's not secant tangent, it's cosecant cotangent. And once again, we do have that negative in front. Next one, derivative of ln of x. ln of x. This one we've done a lot of in recent memory because in the previous unit, we did a lot of antiderivatives using ln of x. So it's 1 over x. Derivative of log base a of x. This one is not very common, so I wouldn't, it wouldn't kill you if you don't remember it, but it is fair game on the AP exam. So it's 1 over x, again, just like the derivative of ln of x, except this time you have multiplication by 1 over ln of a. So ln of whatever that number is. So for example, if we did like the derivative of log base 2 of x, that would be 1 over the ln of 2 times 1 over x. So that would be an example of what a problem like that would look like. But once again, that is not a very common one, similar to how cotangent, secant, and cosecant are not common derivatives. This is not a common derivative that you can see, but it is fair game. So next one, derivative of e to the x. This is one of the more easier derivatives we ever did, is just itself. The derivative of the inverse sine. This is one of the ones where we did prove in class where it came from, but in terms of remembering it, it's probably best to just memorize it. 1 over the square root of 1 minus x squared. Derivative of tangent of x, inverse tangent of x, 1 over 1 plus x squared. Next one, derivative of secant inverse is 1 over x times the quantity, or times the square root of the quantity x squared minus 1. So those are the 3 common inverse trig derivatives that you'll see, at least in the last, I think, like 20 years. Those are the only 3 that have ever showed up on the exam. But I would say that inverse sine and inverse tangent are definitely more common than inverse secant. So if you had to remember at least 2, those 2 I would definitely memorize. All right, so we did those ones. The derivative of an exponential function, so a to the x power, is itself times ln of a. So for example, if we did the derivative of 2 to the x, that would be ln of 2 times 2 to the x power, so times itself. Next one, so this one is when you take the derivative of an inverse function. So when you take the derivative of the inverse function. So this one you would do 1 over f prime, so the derivative of the original function of f inverse of a. So 1 over f prime of f inverse of a. Once again, not a huge topic, probably only one problem related to this that you'll see on the AP exam, but definitely good to know. Mean value theorem, I don't know if you remember this one. So this one says given a function is continuous and differentiable, then there exists some value such that the derivative is equal to the slope. Okay, so this is so that's basically what it's saying, that there exists some value in that interval, some x value in that interval, such that the derivative is equal to the slope between those 2 points. Okay, the slope between those 2 points. Then we got a critical number or a critical point or a critical value. Those are all one and the same. So that is any input value, in most cases an x value, that makes the derivative function either equal to 0 or undefined. Always remember, a lot of people remember the 0 part. Don't forget it is also what makes it undefined as well. So don't leave that out either. And then f of x is increasing. When is f of x increasing? If you recall, remember, you always want to think of the first derivative. F of x is increasing when f prime is positive over that respective interval. When f prime is positive over that respective interval. F is decreasing when its derivative is negative over that interval. And recall the way we did this, the way we figured out whether something was increasing or decreasing, is we typically used a number line, right? We found out those critical numbers, put those critical numbers on the number line, and then just found out if it was positive or negative to the left and right of those critical values. First derivative test max, so using the first derivative to determine a max. So a function is said to have a relative maximum at a critical number, keyword critical number, if f prime changes from positive to negative. Now first, remember, just because it's a critical number is not enough to make a conclusion whether it's a minimum or a maximum. You have to know, or you have to verify that the derivative changes from positive to negative. And once again, we did that by just using that number line, testing values to the left and right of that critical number. First derivative minimum is basically the same thing, except this time it changes from negative to positive, right? So it goes from decreasing to increasing. Okay, so it goes from decreasing to increasing. That would give you your minimum. at that critical number. Now we have concave up. So remember, increasing or decreasing is looking at that function's first derivative. Concave up, concave down is looking at that function's second derivative. So that is when the second derivative is positive over the interval. And then concave down, another way to determine it or to justify it is by saying that f prime is increasing. So on a free response question on the AP exam, either of those would be perfectly acceptable explanations. Either saying that f double prime is positive or by saying f prime is increasing over that interval. And then concave down, f double prime is negative or f prime is decreasing. F prime is decreasing in that interval. Second derivative test minimum. So remember, you can use the second derivative to determine whether the original function has a minimum or a maximum. So you find when the first derivative is equal to 0, and if the second derivative is, if the first derivative, is equal to 0 and the second derivative is concave up or greater than 0. Now the reason why this works is, remember, concave up means, the visualization that we used in class means that it looks like an upwards facing parabola. So this is basically just saying that your graph looks something like this. Your first derivative is equal to 0 and it's concave up, so that's why it's a minimum. And then finally, second derivative maximum would be the same thing. Your first derivative is 0, but your second derivative is negative or it's concave down. So it would look something like this, so that's why there would be a maximum at that point. And then finally, the derivative of something to a power. This is just the power rule, people. Just the power rule. Now, some of you might remember this verbally. Some of you might recall what this looks like symbolically as well. So remember, you bring the exponent down. So the exponent was originally an n that goes in front of the function equation now. And then we subtract 1 from the exponent, so n minus 1. Okay. So once again, hopefully you tried out these before you watch the video. See how much you get right, or you got right. So once again, and we're actually going to continue this tomorrow as well. Please make some flashcards out of these, whether you print out the document that I will be posting and then just cutting it out into rectangles, or just putting each of these on its own separate note card and just testing yourself to see if you remember these. Once again, these are all concepts and terms that you need to know for the AP exam, just by memory. So tomorrow we're actually going to continue on with another group of concepts and ideas that you need to remember. So this was our first day of review, people. This is not the only thing we're going to be doing. We're not just going to be doing flashcards. We are eventually going to be looking at some free response questions. But otherwise, like I said, I will update you guys as soon as College Board tells us more. I hope you guys are staying safe. I hope nobody's getting sick. And I hope you guys are, at this point, not getting too bored. I hope you guys have a good rest of your days, and I will see you later.